Welcome to Syntax. On this Monday hasty treat, we're going to be talking about Docker. Myself, Scott Talinsky, I don't know that much about Docker. I use it whenever I need to toss something up on my NAS or host something, but I don't work in Docker very often. And when CJ submitted a pull request to the Syntax repo to add Docker support to our repo, I thought to myself, I need to ask CJ a lot of questions about Docker. So that's really what this episode is going to be. I have a whole lot of questions in general, and the concept is going to be from just an average web developer's perspective, what this stuff is, why you might use it, why you might want it in your code base, and just a little bit about understanding about Docker if you've never used it before. Again, my name is Scott Talinsky. Wes Boss is out today, so we have my dog barking, but we also have CJ. CJ, how's it going?
It's going good. Happy to be on the pod. This is exciting. Yeah.
Yeah. I'm going to apologize. Right now, my dog, in fact, she might make an appearance because the garbage truck's coming by and I need to give her a hug. Yeah, she does well with hugs, but she doesn't do well with garbage trucks. Speaking of garbage, sometimes your code is garbage, and that's why you need Sentry in your code base. So head on over to sentry.io, and you can make your code less garbage. For instance, you can instantly see, like I'm talking right in a big old table after you add this thing, exactly what's going wrong with your code base, how many bugs your code base has. But like the big thing for me was like performance. I was seeing which pages gave our users the most misery, which was, they call it a user misery score. And it's like, all right, this page is being hit by a lot of people and it's the slowest. Therefore, the misery score is higher. If this page is, it's a little slow, but not that many people are hitting it, it prioritizes a little bit lower for you. So that way you're getting the biggest impact, the 80-20, right? You're able to solve the biggest performance bottlenecks in your application that people are actually hitting. There's a billion features in Sentry, so check it out at sentry.io/syntax. Sign up and get 2 months for free. All right, CJ, first question for you. What is Docker?
Sure. So I like to describe it as easily reproducible environments. And I think someone had the tagline, but it was something like it works on my machine is no longer an excuse. So the idea that you can bundle up some collection of configuration and use it in multiple places, whether it's local, like in just other developers on your team's environment, or whether it's in production. And so that's one of like the major benefits is you can kind of like craft this little environment and it'll work locally, but then you can use that exact same environment when you're working like on your staging server or in production or whatever else. And Docker actually is containerization technology. So it is not a virtual machine. So virtual machines actually emulate entire bits of hardware. So if you've ever used a hypervisor like VMware or VirtualBox, for any operating system or any machine that you create, it is literally emulating the hard drive, the disk drive, the CPU, the GPU. It's creating virtual versions of all of those. And that is one way of kind of like creating a reproducible environment, but there is a lot more overhead because it's having to emulate everything. But Docker is a containerization technology. So it's also known as operating system level virtualization. So instead of having to virtualize and emulate all of the attached hardware and everything else, every virtualized container actually shares the base operating system kernel. And it can essentially be a bit more performant and not have to use as much resources because it's not having to emulate and virtualize all of the associated hardware as well.
Nice. So that's interesting that you get that point that it's not a virtual machine, because when I think about Docker, the first thing that comes to my mind is it's a virtual machine, but apparently it's not. So that's great to know.
I would say it's a little white lie. So like depending on where you're running it, might not be completely right on this, but because let's say you're running Docker on Mac OS, if it needs to virtualize like a Linux operating system and it needs the Linux kernel, it's possible that Docker Desktop, like on Mac, actually does spin up a tiny VM. And then especially like on Windows, it does. But if you're in a pure Linux environment, there are no virtual machines at all.
So it's not inherently a virtual machine. Yeah,
right.
Cool. Yeah, cool.
And one thing I will add, just because I know there's a lot of people out there like, well, you're talking about Docker, you should talk about other things too. So because this is like a general idea of containerization, there are alternatives. So Docker is kind of just like brand name containers, but there's also things like Podman, Containerd, Builda, LXD. I haven't used any of these, but I think these things are starting to pop up because people do want alternatives to Docker as well. So I think it's worth mentioning that all of this containerization stuff that we talk about is applicable to other things, not necessarily just Docker and Docker Desktop.
Yeah, and Podman has a cool name and a cute little like Doug Trio seal logo. Gotta
Yeah.
love that. Yeah, maybe I'm gonna go Podman just for the logo and vibe. Okay, so as a developer, right, we're
Mm,
building websites. And I know you said like it works on my machine isn't a thing, but like why would somebody building websites like pick Docker to use as opposed to just YOLOing it on their machine?
for sure. For me, I think like one of the easiest ways to get started with Docker is not necessarily even containerizing your apps, but just using like databases that are in a container. Because if
Hmm.
you're building a full stack web app, it typically talks to a database of some kind. And so you can take these pieces of your architecture and kind of like operationalize them. So let's say you have a MySQL database, like in the case of the Syntax website. That's basically what I did in my pull request. I didn't containerize the SvelteKit app. I just made a little Docker Compose file that says, you should spin up a MySQL database and it should use these environment variables. So that way it's kind of in sync with the SvelteKit app that's running on the machine. So before that, the documentation that Scott had wrote was basically like, you should have MySQL running on your
Yeah.
machine.
Yeah.
And
Yeah.
for some people, that's hard to do. Like, I mean, you have to figure out, well, how do you install it and how do you configure it? The nice thing about this Docker Compose file that I added is you literally just say Docker Compose up, that spins up the MySQL database, and you're good to go, regardless of what operating system you're on or whatever else. You don't have to go through all of those steps to kind of like set it up. And so for me, that's kind of like the biggest selling point is you have new developers on your team or you're working on an open source project that other people want to be able to contribute to. It's so much easier to contribute if you can literally just like run one command from the CLI and your
Mm.
entire environment is up and going versus like following a README of install this, now install this and configure that. So that's basically one of the main benefits here is it's reproducible and you can use it for a lot of different things. And especially if you have a more complex architecture. So let's say you don't just have a full stack app and a database. Let's say you also had like a separate front end, a separate back end, a SQL database, a Redis database. You have the ability to containerize each of those things and then use something like Docker Compose to like kind of make them all talk together. And so, yeah, I think that's mainly it is like it's easier to work with others. And then it's also kind of like it operationalizes the things that you're manually doing every time you have to start up a specific project.
That actually makes a lot of sense, especially, I think the thing that I like the most there is that you directly tied it back to a deficiency in our onboarding process,
Mm,
which when I was tasked with making the onboarding process smoother, there were like a number of things. I was like, I don't know, there are challenges that I haven't necessarily had to face with not working with remote code, remote database, even
mm,
like the Level Up Tutorials code base. We were working on a remote database 100% of the time, even if it was staging, just because it
see.
was easy.
Yeah.
But having that ability makes a ton of sense. How do you get started learning Docker and applying it to your work?
Definitely. So, first of all, download Docker Desktop. And once you install it, they'll actually have a command you can run for like a little hello world. But my main advice is start with the docs. Like their docs are immense. Like everything you could ever want to do is really well documented. And they also have an official tutorial. So there's the Docker 101 tutorial, and that will walk you through creating containers and just the whole process of like using the Docker CLI and Docker Desktop. So yeah, I highly recommend the official documentation. And in terms of getting started, I would just like, learn the basics and then try to containerize something. So if you have like a Node.js and Express app, figure out how to turn it into a container. Basically, like use some of your existing apps so you're kind of familiar with the process and then start diving into trying to set it up and get it going with Docker.
Yeah. Okay. So can you maybe like tell me a little bit about how does it all work necessarily? Like you often hear things like there's Docker files, right? We have containers, which we talked about, images. Like what is all this stuff?
Sure. So I'll do my best to describe all this, but we're going to start at images because that's kind of like your first entry point into it. Especially like if you spin up a database with Docker, you're pulling potentially from an image that has already been created before.
Hmm.
So images can be hosted in various places. So Docker Hub is the main one if you're in like the Docker ecosystem, but people have and frameworks and tools have created base images that are ready to go. So you can find an official MySQL image, you can find an official Node.js image, or Postgres image, or Redis image, or PHP image, or Laravel. Literally pick a tech, and someone has created a base image, and very often it's like the official one from actually like the core team and the creator of that tech. And so that base image has an environment ready to go with that specific tech. And so it's all based on Linux. So it's like a base Linux operating system, but then anything that is required for that thing to run, so like various dependencies or whatever else, has already all been installed, and it's kind of just ready to go. So you can pull from those images and just get them up and going. Like, you actually don't have to write even your own Docker file. You can literally just, with a single command line, just pull an image and start running it on your computer. So images are kind of like the base at everything. And Docker Hub is just one place to get images. Like, there is actually this registry specification. So there's a lot of different places that can host images as well. So you can actually host images on GitHub. And even if you have like private repos, so this is what some companies will do, is like if they already are on like the GitHub Pro plan, you can actually publish your own images to your Git repos as private. So like if you have a specific setup that you want to use in your apps at your company, but you don't want to share it with the world, you can push that to the GitHub registry. GitLab also has this. There's a thing called JFrog Artifactory. So this idea of like hosting images in places that are reusable by others is there, and it's not just specific to Docker Hub.
Nice. I feel like I have used Docker Hub on my Synology to grab images for MB or Jellyfin or those types of things.
Right.
Believe it or not, there is a Sentry you can self-host. I don't know if people know this, but you can self-host Sentry, and there's a Sentry from Sentry themselves. There is an image. I couldn't come up with the word. There's an image there. I got it. Thank you, CJ.
I think you're kind of seeing the idea of how this all is puts together now, because if this didn't exist and you wanted to get going with Sentry on your local machine, you would literally have to follow the docs, right? Like, install this dependency, install this, and then finally maybe you can get Sentry running. But now it's literally just an image you can pull down and you're up and going.
Cool.
So images are the base, and like I said, you're kind of like your first exposure to Docker is maybe pulling from pre-created images, but you can also create your own. And this is in the form of Docker files. So you start with a Docker file that basically describes the environment that you would like to create. And this Docker file has various layers. And the first layer always is a base image. So you're always starting with some base image. And a lot of times you'll start with something known as like Alpine Linux. So Alpine Linux is a distribution of Linux that is very minimal. Like, it doesn't have a bunch of extra stuff. So it's like super small. So that way your base image can be super small. And then you can start to install packages and dependencies from that base image. So actually, let me pull up an example Docker file, and I'm going to describe what's happening in there. In this example Docker file that we're looking at, the very first line says from node:/lts-alpine. So that's our base layer. It basically says, and to take a step back, we are describing a Docker file that will containerize a Node.js application. And so the base layer there is the node image. And so they've already done all the hard work of configuring the Alpine Linux system. They've installed Node, they've installed npm. It's kind of just ready to go. And so that first line gives us a Node.js system. The next line installs a tool for running processes in the background. So I have a line here that says run npm install pm2-g. So this image is going to have pm2, which is a process manager, pre-installed in it so that it can keep track of the Node app that is running. My next line in there is the working directory. So this is where the code exists. So working directory, user source app, that's where the code will live inside this container. And then we copy the package JSON in, do an npm install, copy the source code in, and then the last line in this file actually says to use pm2 runtime to start up that Node.js application. So this next idea here is that this one file kind of describes all of the steps needed to get a base Node.js image, to install the dependencies, everything else, to kind of just compartmentalize that process of having a Node.js application. And so I've described this in a Docker file. What I would do is actually build this Docker file into an image. So this Docker file then becomes an image, and now that image is reusable. And a lot of times you'll actually ship this Docker file in your source code. So when other devs come to your code base, they'll actually run a line that builds that image locally using that Docker file.
So that file seems pretty easy to reason about to me. some of the copy stuff is a little weird. The copy package Astra stuff or the
Yeah.
copy dot dot. That stuff feels like a little weird to me just
Yeah.
looking at it. But the rest of it you can kind of reason about. I'm sure there's complexity degrees to all this stuff. Do you
Yeah.
find typically that those are easy to author, or is that like a big learning curve?
I would say like I definitely come from like a system administration background, so like I've written a lot of bash scripts and stuff like that. And so
Yeah.
from that perspective, like if you've ever written any kind of bash script or like any kind of like run this, then do this, then do this, this is very similar to that. And their docs kind of describe what all of these things are doing. So like copy literally copies files from the directory you're in into the image that it's building. Yeah, but in my experience, especially for like a simple Docker file like this, the commands are kind of just like run, copy. That's kind of as complex as it gets.
Nice.
And then from there we have containers. So containers are actually running images. So we have our Docker file, we build that into an image, and then when I actually want to run this thing, it is described as a container because it's actually a running image. And so the other way to think about these Docker files is that the layers are like cacheable. I don't want to get too complex too quick, but the idea here is that if you have a system that needs to build these Docker files fairly often, you don't want to have to run the same steps every single time you build that Docker image. And so each line in this Docker file is actually a cacheable layer. And the first time you run it on your machine, it's going to take a little bit of time. But the next time you run it, as long as none of the layers above it have changed, it can completely use the cache version of that layer. So yeah, that gets into the complexities of it. But for the most part, you got your Docker file, describe your environment, and then what command is needed to actually run that thing.
So if I were to say like, all right, add Docker to X, Y, and Z project, it's as simple as writing a Docker file.
Yes, yeah. And I mean, like I said earlier, like one of the first steps you might try is just bring in a database. And from there, you actually don't even need a Docker file. We'll talk about that in a little bit. You can actually just have a Docker compose file that says, hey, I want a Mongo database or a SQL database. But yes, if you have like a Node app or a SvelteKit app and you want to turn it into an image, you're gonna author one of these Docker files.
Cool.
So yeah, like you said, create the Docker file, kind of describe the environment, and then you're good to go from there. I would kind of like look at Docker Hub or wherever you're pulling those images from to find what your base image is. In the example of Node, there's like the Node LTS Alpine that you typically will pull from. That's the other thing is in terms of versioning. So LTS is long-term support. And so that line describes which image you're pulling from. You always want to have a version number on there. Like if you don't put the version number, it's always going to grab the latest, and then your images might actually break. Then it might actually turn into it works on my machine scenario because you didn't lock it down to a specific version. And so I would also recommend find projects out there that have existing Docker files, Docker Compose files, and learn from them. That's basically mostly what I learned from is I was seeing existing examples of apps that were using it, and then just kind of like started to piecemeal my own versions of that to get it working with my applications.
Cool. So like you have the file, right? You have either and we'll talk a little bit about Docker Compose in a second, but like I have this thing in my repo. How do I say, hey, go do the thing?
Sure. So yeah, there's a CLI. So there's a Docker build command. So you'll run Docker build. I would pull up the docs because it's going to be specific for like every project, but you'll run a Docker build that will actually create the image. And now that image just lives on your computer. And then from there, you can do a Docker run and you specify the name of the image that you just built. And so then it'll be up and going. I'm probably going to get into this a little bit later, like when we talk about like gotchas and stuff like that. But the idea of like containerizing your app, you also have to think about development, right? So if I'm working in a system where whenever I change the file, I want the server to auto restart or like the page to auto refresh, you have to do some specific things with Docker if you want to get that experience. And so that gets into the idea of like volumes and mapping your local computer into the container. And so that is a little bit trickier. And I think it is definitely like a gotcha of a lot of projects. If they just immediately jump into, well, we're going to Dockerize everything, your dev cycles can start to get much slower because now all your files are living in the container, and then so like you save them locally, they go to the container, and then there's like a round trip, and so like your hot reload and your refresh is a lot slower than it used to be. So if you're going to add this to your project, start with databases, then try to kind of like add a volume, get this hot reload working. But if it slows things down, don't use Docker for that part of your app. That's my advice there, because too many people just try to go fully gung ho on Docker, and then your dev experience starts to tank from there. So yeah,
And then you never touch it again because you're like,
exactly.
this sucks. Right? Yeah.
And I think that's what has scared a lot of people away from Docker potentially. But yeah,
Yeah. What scared me away, well, not scared me away because I use it to host
yeah.
stuff, but like I was running a code server on my hosting setup, and I
Hmm.
was running a code server, and all I wanted to do was be like, the code server was saying, you need to find config.yaml to get the password for code server so that you can sign in. And
Hmm.
then, so I've SSH'd into my machine, and I'm like, where the hell is this container and where is this config file? Like
Yeah.
where, like, what I had to do is I think I had to then SSH into the container itself. I don't even know what I did, but I ended up getting into the container environment, and it was in the user directory of the container itself.
Hmm.
So that stuff is tough to reason about when
For
you're
sure.
trying to figure it out. Yeah.
Yeah, and I guess what I would add to that is typically you would do like a Docker exec, and so you're executing a command inside the container, and so that's what allows you to get into the container. So if you do a Docker exec of like Bash, now you have a
Mm,
Bash shell, but it's technically running inside the container.
that's what I did.
Yeah, so a lot of times you might need to do that to get in there and configure things, but I don't really think I even touched on this. The Docker containers are ephemeral, so like the idea is if you spin it up, if when you spin it down, if you haven't mounted any volumes, all of those changes are lost. And that's kind of a good thing because it's like that forces you to make things reproducible in your config. But you do have to remember that, like, if you get in there and like do things via like Bash and change some stuff around, the moment that container goes down, you're going to lose those changes.
So you mentioned Docker Compose a little bit ago. What is that? How does that relate to everything that we're talking about? And what is that?
Yeah, and so yeah, I touched on it a little bit, but the whole idea is to kind of orchestrate a complex architecture. So
Mm.
an example app I have has a Redis database, a Postgres database, a Svelte front end, and like an API backend. And I want all of those things to be running at the same time, and all of them are pulling from different base images. And Docker Compose allows you to kind of like orchestrate that stuff locally. So you have a Docker Compose file that describes each of your services. So you would have like a DB service that's pulls in your specific base image, defines all of your environment variables, decides which ports to expose, and then you can also have another service in there for your backend application, potentially one for your front end application. And so this is a configuration file that kind of describes all of those services. And then with a single command, you can spin them all up and then bring them all back down.
That's awesome. Okay, that to me is a very good selling point.
Yeah.
Especially given that I'm working with so many of these technologies, as you have mentioned, in that the kind of do it yourself every step of the way kind of way, and it does
Yeah.
feel like kind of a PIA a lot of times. So you mentioned some gotchas. I want to hear about the gotchas.
For sure, and I'll make these quick, but I think the main thing is you do need a lot of CPU and RAM. Like if you're running all of these services locally, you got to make sure you have a plenty of resources. I mentioned earlier that idea of like live reload and auto refresh. It's gonna slow things down. It absolutely will. So take that into account and decide whether or not you actually want to containerize that part of your app. And then the other thing is potentially conflicting services. So if you have MySQL installed locally and you try to spin up a MySQL container, you're going to have to make sure that you expose a different port than the port that's actually running on your machine. And then just in general, disk space. So like as you start pulling these images, your hard drive is going to start to fill up as well.
Yeah, because you need to pull a lot in when you pull in the images. What was I trying to do? If you use the GitHub Actions locally
Mm,
to run GitHub Actions, which is all through Docker, it
yeah.
like, man, it pulled in like 60 gigs when I
Yeah.
had to get that going. I was like, what is going on here?
Yeah.
Did I do something wrong? Is it? Yeah. Okay. So let's say I'm sold. I'm at least
Mm,
curious. I'm Docker curious.
sure.
What are your favorite resources for picking up or diving in a little bit more? Because I am.
Definitely.
I'm genuinely interested here.
Yeah, I would say the docs. Like I said, the docs are expansive. That can kind of be a turnoff just because there's so much of them.
Hmm.
Um, so I would start there. But I personally I like to learn by example. So I try to pick some existing projects that are out there, look and see how they've set things up, and kind of just copy paste and go from there. The other cool thing is when you're looking on Docker Hub, all of these various images a lot of times will have example Docker Compose files or example Docker files that show you how to use that thing. So even just looking on Docker Hub, you can get a good idea of how to use a specific image. So that's my main thing is just get in there, get your hands dirty, and you'll figure it out.
Nice. Well, this has been awesome, CJ. I think it like cleared up a ton of big things that I had about Docker. And I hope anyone out there has gotten a good handle on it, because it is one of those things that people just kind of talk about it like everybody knows and understands it. I've made it this far in my career with being able to even use Docker without truly understanding it. So
Yeah.
I really sincerely appreciate you taking the time to
Definitely, yeah.
answer my dumb guy questions here. So yeah,
Of course.
thank you. So that's all for now. Thanks again for CJ. If you liked seeing CJ and you liked hearing him, head on over to the Syntax YouTube. It's at Syntax FM on YouTube. There's a lot more CJ there. And Wes will be back next week, and who knows what we'll talk about, but we'll catch you then.
Awesome.
Peace.
Peace.